Welcome back for the rest of lesson 1-5. So today we're going to dive into slightly more complex situations. Yesterday we dealt all with just simple inequalities. Today we're moving on to complex inequalities or compound inequalities. So dealing with more than one at a time. All right, so there's two types we're going to deal with, the and situation and the or situation, okay? We're going to talk about the differences and similarities between them. So the important thing here, when you're dealing with an and inequality, is you're looking for things that make both true. So for and, you are looking for the overlap. So you're going to want to graph both, but then you're going to want to highlight the overlap because that is really what makes it true. Both have to be true at the same time. Okay? So let's take a look at how that plays out. So obviously you just have to solve both of them, right? So here, I'm going to subtract 1 from both sides. So 6 is less than 2x. Divide by 2. And now, of course, again, as I always say, is easiest when the variable is on the left. So let's reverse that, which also reverses my inequality. Okay? So x is greater than 3. Okay? So I'm going to do that. X is greater than 3 looks like that. All right? And now I'm going to solve this one. Well, this one is easy. Just divide by 3. So x is less than or equal to 6. So that is going to look like this. Less than or equal to is filled in. Less than is going this direction. All right, so for the and situation, once again, what that means is I want to highlight the overlap, okay? That's the only piece of this that I actually want. Well, the overlap exists here, okay? So I put the endpoints and connect them up. So the black, this is my actual solution right here, okay? Then, of course, written out, you have both of those pieces. But the graph, you need to highlight that black section for me, okay? That is really the only solution for the and. The overlap is it, okay? So what about this one? Well, same type of deal, okay? So here I'm going to add 1 to both sides. So 6 is less than 3x. Divide by 3 on both sides. Again, is easiest if I reverse that, which reverses my symbol. So I have this. So open circle at 2 and greater than. Then this one to solve is pretty easy. Just divide by 2 is less than 6. So open circle at 6, like that. And again, and just means I want the overlap. So I put the two ends, and then it's only that overlap piece. Only the black is the solution. So you have to make sure that you indicate that to me. Okay, that is the only part that is the solution. All right, now, there is this idea of compound inequalities written in a collapsed form. So when it's in a collapsed form like this, okay, just like that, all that means is that you do operations to every piece of the inequality, okay? So all that means is here, when I have to subtract 4 to get x by itself, it means I just subtract 4 everywhere, okay? And then that is actually really, really easy to graph because between 1 and 8, all you have to do is the middle in between there, okay? And I knew open circles because obviously it was strictly less thans that I was seeing, okay? So collapse form is actually really easy, and I just want to make sure you have some exposure to it because it does show up when you're doing absolute values in the following section. But otherwise, really easy. Just make sure you're doing each thing to every single piece that you see. All right, some tricky situations that can show up, okay? Or I should say some interesting situations that show up. So here, I'm going to want to divide by -2. When I do that, remember it reverses the inequality. So here, less than 6 is going to put me like that. Then I'm going to oh, add 2 to both sides. So x is greater than 13. And whoops, that actually takes me off the graph. 11, 12, 13. Now notice, here I have a dilemma, right? Because here and means that I have to find an overlap. But in this instance, there is no overlap, okay? So when that's the case, when there's no overlap, just put no solution, okay? For the and, if there's no overlap, there is no solution, okay? So tricky situation number 1. Other tricky situation, let's look at the other side. So here, x divided by 3 is greater than 1. I'm going to multiply both sides by 3. Okay, so here, oops, I should have done that in a color. I apologize. So x is greater than 3, and I'm sorry that this is so tiny. And then here, subtract 1. So x is greater than or equal to 7. All right, so here, the interesting case that arises is the fact that the overlap actually goes on forever, right? It's not this little closed out section. They're overlapping as they're increasing. So here, what you'd want to identify is that as your solution, okay? If they're overlapping, heading in the same direction, well, you still just do the very same thing. You take the point where the overlap begins and then continue off in the proper direction, okay? Again, just to make sure you've had exposure to any situation that could arise. So that's everything with and, okay? Again, and meaning that you need overlap. Now, let's begin talking about the other situation, the or situation. So the or situation, find solutions that make either one of them true. So in this case, it's not an overlap. It's whatever you graph just is the solution. Okay? So let's take a look at what that means. So for this one, I'm going to subtract the 5. So -2m is greater than or equal to 16. I'm going to divide by -2. When you divide by a negative number, remember it flips the inequality. So here, m is less than or equal to -8. Will look like that. And this one, I'm going to subtract 3m. I need to get the m's together. 2 minus 3 gives me -1. Divide by -1. But when you divide by -1, you also flip the inequality again. So just like that. And for or, everything graphed is your solution. So that whole thing is your solution this time, okay? Because or Only one of them has to be true, one or the other. All right. So all you have to do is make sure that you just leave everything, and that is your final answer for this one. All right, let's take a look at these. Again, to continue working on this. So let's subtract 3 from both sides. So 7w is greater than 8. All right, so here, divide by 7, so w is greater than 8/7. Well, graphing wise, it's always easier to do a decimal. Well, 8/7 is about 1.14. Okay, so I'm going to plot that. So w is greater than about 1.14. And let's take a look at our other side. So I'm going to subtract w. So 5 minus 1 will leave me with 4w plus 1 to both sides. Negative 13 plus 1 is negative 12. Divided by 4 is going to be less than negative 3. So again, strictly less than means open circle, going that direction. And again, because this is an or means you just copy down anything you see as part of your solution set. Okay? Everything is part of your solution. And again, it's okay if you get something decimal. Just do it the best you can. All right, so once again, I want to caution you about some unique situations that can arise. Okay? So let's take a look at these. Both of these are or. So again, or means everything. So subtract 3. So y is greater. Oh, I am sorry. That is not minus 3. Minus 2. My brain was getting ahead of me there. Y is greater than 3. Or here, we're going to divide. Oh, I should switch color. Divide by negative 2. So y positive 9. Flip it. So y is greater than or equal to 9. All right, now this time is a unique situation because right here there is an overlap. But remember, or does not need an overlap. Or means anything works. So this time when you copy it down, that encompasses everything, okay, that you want. So in or, if they're facing the same direction, you want to go with the bigger one, though, or the one that you see more of, I should say, okay? Because everything needs to be included still, all right? Well, what's another unique situation that can arise? So here, going to add 1. So 2z is less than negative 4. Divide by 2. Z is less than negative 2. Then here I'm going to subtract 2z. So z is greater than negative 7. Now here notice once again, this is an or. So or means everything that you see is a solution. Well, if you notice, in this case, that's actually everything. In the or situation, if they cross and they're going opposite directions, that encompasses the whole number line. So for or, that means everything is a solution, okay? So you do have to be very certain that you understand the difference between and or, and how all of these cases can play out, okay? And what I might recommend is actually including that to be part of the summary you're going to write for me right now, okay? Write to me about these differences, about how you handle these situations, okay? Because being able to handle the situations is going to be critical to being able to do the practice work and doing well on the test. So take a moment and fill that out for me, and then come back ready to do your practice work.